I'd like to introduce Chuck Benbrook. He served as the chief scientist for the Organic Center for the past 7 years, was executive director of the Board of Agriculture of the U.S. National Academy of Sciences in the 1980s. His work is focused on the impacts of farming systems, technology, policy on food safety, human health, and the environment. And he's just recently joined Washington State University to develop a new program entitled Measure to Manage, Farm and Food Diagnostics for Sustainability and Health.
I'm going to take us into the dark and murky world of pesticides. I was going to talk about both nutritional quality and pesticide residues and risk, but the brand new data from the U.S. Department of Agriculture came out and includes an intensive sampling of apples. So I thought I'd focus on that today. So let's see. Do I have to point it here? There we go. Okay. Well, just to start out, why are there pesticide residues in apples and in this case Washington apples? This is the last time USDA surveyed pesticide use in Washington State. You've got 18 acre treatments with insecticides. This is of course all of Washington apples, and including organic apples, and very significant insecticide and fungicide applications, and this is why obviously there's some residues left to deal with. And this is number here, 4.9 acre treatments and 3 pounds of organophosphates. That's where the bulk of the dietary risk is, and also the environmental impacts. We've developed and use a dietary risk index to do a relative ranking of pesticide risk from a serving of one food compared to another food. I'm going to quickly walk through the methodology so you understand what this metric is all about, and then I'll present a lot of results on apples and peaches and a few other tree fruit crops. The dietary risk index is basically it's a ratio of the mean residues or measure of the mean residues in a particular type of food relative to the amount of pesticides that can be in the food without exposing a person to a higher level of the pesticide than is considered consistent with the reasonable certainty of no harm standard embedded in federal pesticide law. The residue data comes from the very high quality, well-trusted pesticide data program, and they test about 25,000 samples a year, and there's both domestic production and imports, and countries of origin and states, and by downloading the raw data, you can do a substantial work on the distribution and trends in risks. The DRI as a basic measure, it's very simple. It's the mean residue level divided by something called the chronic reference concentration. This is the maximum amount of pesticide, as I said, that would be allowed in a serving of food. And by allowed, I mean consistent with what EPA calls its level of concern. So this reference concentration mathematically is quite simple. This is the chronic reference concentration, which is in milligrams per kilogram, and you multiply that times the serving size of food that a person ingests in a day. That defines a amount of pesticide consumed per day, and we set the chronic reference concentration based on the weight of the person and the CPAD. This would be the chronic population adjusted dose, which is basically the measure of the toxicity of the chemical. To calculate the CFRC, you just divide both sides of the equation by serving size, and you have your number. Most of the work that we've done over the last 15 years, we base it on a typical 16 kilogram kid, which is about the age where children are exposed to the highest concentration of pesticides based on their body size and the amount of food that they eat and whatever the residue levels are. We take food consumption data from the standard NHANES survey. We try to set it at about the 95th level of consumption, and we use the latest tox data from EPA to establish this metric. So for the pesticide data program, raw data from 1993 to 2010, we've moved it into a very powerful access data set. We've linked it up with EPA toxicological data, and we've cut the data every which way. We have a standard analyses, which are composed of 15 tables. There's 4 versions of each table, one encompassing all samples together, a second one all imports together, a third one imports broken out by country, and the fourth domestic production. And when you print all of these, all 4 versions of the 15 tables, the stack would be from about here to here. So it's 4,000 or 5,000 pages of information, but it allows you to easily access the most obscure data about pesticide residues in food for the foods that PDP tests. There's 2 forms of the DRI. One we call DRI mean, which is just the mean of the positives found, say, in apples divided by the CFRC, and then a food supply DRI, and that simply multiplies the DRI mean times the percent positive. And the reason we do that is, you know, PDP will pick up 75 residues in apples, and if you do an aggregate measure of risk in apples based on the pesticides that PDP found in a particular year, and if you use the DRI mean, you're basically assuming that every one of those 74 residues was in the serving of food that you're trying to get an estimate of risk. And of course, that's never the case, and a huge exaggeration. So by multiplying by percent positives, you're really correcting these aggregate measures for the true distribution and frequency of residues as they're appearing in the food supply. And whenever you're sort of comparing risks in food, different types of food over time, food from different sources, you want to be typically focusing on this food supply DRI measure. Now, this is the good news for the Washington apple industry. This chart for several of the tree fruit crops has the trends in DRI levels. This is a pre-FQPA, which is the Food Quality Protection Act, passed in 1996. These are the DRI numbers by crop for combined imports, and domestic is down here. So you could see what the domestic apple industry had about a 2.67 food supply DRI in the pre-FQPA era, and is now down to 0.27. So it's a 90% reduction, really very dramatic. And in fact, across most of the major tree fruit crops and most of the major vegetables, domestic farmers, since the passage of the FQPA, have reduced risk very substantially, somewhere between 5-fold and 10-fold. But as you'll notice, there's been much less reduction in the case of imports, where the some of the pre-FQPA baselines of 17 back at the time the FQPA passed, it's only down to 12.3, or about a 27% reduction. We've done some more sophisticated analysis with these numbers, and the bottom line is that in 1996, when Congress passed the FQPA, domestically grown fruits and vegetables accounted for about 75% of the pesticide dietary risk, and imports about 25%. And today, 2012, those shares are reversed, if not even a bit more. I would say that the residues in imported food are pushing probably 80% of the total risk. And this is it's a big concern for a lot of reasons, but one that's not known by many people is this chunk of risk in imports. It's all coming in, or most of it's coming in the 3 or 4 months in the winter, when people are buying fresh fruits and vegetables from abroad. So just to give you, so now we're going to be several slides on the brand new apple data. Has only been out about 3 weeks. we've just crunched it. 738 samples out of 744 had residues. The average sample had 5.3 pesticides in it, or pesticide breakdown products. An average FSDRI of 0.271, which is higher than we like to see. And compared to organic, the 15 organic samples that had residues and a total of 18 organic, you've got about 452 times the risk level in this all samples. In the case of apples, there's not as big a difference between imports and domestic as we see with some other crops, but there's also some really striking differences among the different countries shipping apples to the United States. We've done an analysis with this apple data set, which we've never done before. We've calculated the aggregate DRI number for all 738 samples that contain pesticides, and this number reflects the residue levels of each of the pesticides found in the samples. And this is the top 10 conventional samples and the top 3 organic samples ranked by this DRI. This is a real hot, high-risk sample from Washington. That number, 95% of that 8.2 was a result of a relatively high level of diazinon. One of the key points to make in any way you cut this data, you can't get away from this finding. Residues of organophosphate insecticides still account for the vast majority of dietary risk. You see the very high percent in most of these high-risk samples. They're up here at the top end of the list because they have OP residues. You notice right here the 3 organic products. This one organic sample almost certainly is a conventional sample of apples. It had I think 6 residues, and the levels of residues were very similar to the average conventional. So I think it's fair to say that this was a conventionally grown apple that either through mislabeling, handling error, or fraud was sold and labeled as organic. All of the other organic samples had very low DRI numbers and were consistent with organic production. The reason that these high-end samples make a lot of difference and get the attention of regulators, this is just a kind of an amazing thing. But basically, there's 487 PDP samples in 2010 of Washington apples. That's 5.5 billion pounds of apples produced. So when you just do the math, each PDP sample represents 37 million servings of fresh apples. So, a few high-end residues do matter. So we have to, we have to keep that in mind. And it's why, we stress, and everyone that analyzes this data, there's a very small number of very high-risk samples and also pesticides. And if we could just deal with those, we would drive down this risk curve very dramatically. Again, very pleased. This is the first time anyone has ever done this. No one has ever calculated actual dietary risk levels for all 700 samples of a crop tested by the PDP based on actual residues found. And this is a fascinating way to look at the data. We just broke it out by decile, and you can see how rapidly it drops off from in the top 74 samples that pose the greatest risk have an average DRI of 1.24. It drops by more than half into the second decile and on down, and anything from the 7th decile on down, we would call this very low risk. So again, there's a relatively small number of the residues that are posing by far the greatest risk. We've programmed the system now. We can do this analysis for any crop, any state, any country of origin, and any year in the PDP data set. In terms of sort of, again, a big picture, look at the relative risk levels, Chile has the highest risk in apples, a little over 0.4. Chilean fruit is consistently the most contaminated and poses the highest risk. It's a real problem for that industry, and I think it's going to have to do. Conventional growers are going to have to bring down these pesticide risks because they really are starting to stand out very significantly. I wanted to mention New Zealand. You've got New Zealand imports were almost as clean as domestic organic. There's something going on in New Zealand that's very good from a pesticide risk reduction point of view. And if it were not for the New Zealand samples, combined with these Chilean examples, the imports would have looked much worse. Let's see, how do I do this? I have 5 minutes. We've made lots of different comparisons, but let me just this captures the difference, but the average difference in risk in organic samples compared to conventional samples, and the sort of take-home finding is that pesticide risks in organic foods are 50 to 200 times less than in conventional foods. So people that are searching out organic food to reduce their pesticide risk, they're making a smart move and they're getting a return on their investment. Peaches is a very high residue crop. The imported peaches really bad, 5.96. The latest data we have on peaches is 2008. But you can see all of the major states, with the exception of New Jersey, are dramatically less than the levels in imports. I'm gonna skip this. Gonna make the point. If you rank the individual samples of peaches for 2008, 98 of the top 100 are from Chile, and then if you look at the low risk 100, 99 were U.S. grown, and the other one was from Argentina. So there's this significant difference in the risk distribution. The Environmental Working Group, as all of you know, puts out an annual Dirty Dozen list and Clean 15. They just put it out 2 days ago. The media is all in a buzz about it. And of course, it'll get people's attention in this state because number one on their list is apples. And the EWG methodology, and if you want to see something amazing, go to this website or just Google EWG Dirty Dozen and Forbes. There's really a quite remarkable commentary in Forbes magazine about the EWG list, which doesn't exactly cover it the way I would have expected them to. These are the criteria that EWG uses. It's very heavily weighted to just how many residues are there, not the level of residues and not how risky the pesticide is. EWG has been criticized for the lack of a firm risk basis in these criteria, and unfortunately those criticisms are valid. We, late last night after the tour, I compared the EWG rankings to our rankings, which are data driven and really grounded in EPA dietary risk assessment. And the bottom line is that if we were to put out a top 12 list, apples probably wouldn't make it, and if it did, it would be number 12. And there's multiple foods. This is the Clean 15. There's a bit more agreement there, but these are all foods that are on our top list that aren't on EWG's. Hot peppers is by far the highest, and these were tested for the first time in 2010. So basically, there's 9 foods that we would put onto the EWG list before some of the ones that are there, and then these are ones that imported foods that belong on the list based on our assessment. And actually, asparagus, imported asparagus here, asparagus appears on the clean list. So there's some real discrepancies. So just the conclusions. There's ample and very high quality data now to track pesticide dietary risk levels, particularly in key children's foods, which are the focus of the PDP program. The implementation of the 1996 Food Quality Protection Act has markedly reduced risks in domestic fruits and vegetables, with much smaller reductions in imports, and actually risks have gone up in some crops since 1996 in imports. I already made this point about the switch in the shares. Just a few OPs account for the lion's share of risk still, despite 10 years of focus on driving them down. There's a very large variability in residues and risk by country. I noted that example with the Chilean apples versus the New Zealand apples. We see that in many other cases. Canadian food is very clean for the most part, and organic samples pose 50 to 200-fold lower risk levels than conventional. Thank you very much.